Hello and welcome. Thanks for joining us today. I'm Kevin Tolly, the founder of the Tolly Group. More about us in a minute. I would like to begin by thanking TechTarget for inviting me to talk to you about a very relevant and important topic. Endpoint security has been around for decades. In fact, Norton Antivirus started shipping over 30 years ago in 1990. Endpoint protection has evolved considerably and is not likely ever to go away, as the need for security is not going away. But as the industry moves forward and as companies evaluate upgrade options, it is important to remember that your evaluation criteria have to evolve as well. Today, I will be discussing 3 areas that should be of interest to network security specialists: resource efficiency, efficacy or effectiveness, and the new approach of hybrid detection and remediation solutions. Before we review today's agenda, let me take a moment to introduce you to the work that we do at the Tolly Group on the following slide. Our focus for decades has been to help vendors prove their marketing claims with respect to IT solutions. The reports that we publish, in turn, can serve as proof of concept studies for use by prospective customers, saving both the customer and the vendor the time and resources required to prove the same claims again and again. As the slide notes, we have worked in many different areas within the IT ecosystem. We've published close to 2,000 reports commissioned by hundreds of vendors, from leading edge startups to industry giants such as Dell, Broadcom, Huawei, and so forth. You can check out these reports at our website listed here. Let's take a look at our agenda for today. We have 3 areas to look at today. First up is efficiency. Specifically, we will be looking at how different endpoint security solutions use the endpoint's most precious resource, the system CPU. Then we will look at some considerations surrounding efficacy. Specifically, what happens to efficacy, to effectiveness, when the endpoint does not have real-time access to its cloud-hosted threat intelligence resources. We have anonymized Tolly test data to provide you factual insights into the first 2 topics. Our third topic is about awareness of a new approach. I wouldn't call it a trend, at least not yet, where multi-vendor solutions work in tandem to secure an endpoint, and could be a game changer for IoT devices. Finally, we'll finish up with a recap. That's a lot, so let's get going. By efficiency, we are referring to how the endpoint solution uses the resources of the host system. Because endpoint protection is always enabled, this is a legitimate concern. Fortunately, Microsoft Windows and other endpoints have a lot more memory and CPU power than in years past, so RAM or memory footprint and idle CPU are not generally concerns. What can be concerning is what happens when the endpoint protection solution needs to scan a folder of files for malware. In the examples we will be looking at, we will be noting the CPU resource usage when different solutions scan a folder containing 1,000 malware samples. What we have observed is that different solutions can demand very different amounts of CPU resource during on-access and on-demand scans of, say, 1,000 files. Why do we care? Well, every application running on the endpoint requires some CPU resource. If the endpoint solution takes most or all of that resource for the duration of its scan, other applications will likely exhibit degraded performance. If the scan takes a long time, and we've had test runs where the scans take more than an hour, the endpoint is effectively unusable until the scan is complete. So, understanding the type of application and file use is certainly important in determining the likely impact of CPU inefficiency that it will have to your environment. Suffice it to say, it is generally better to have a solution that makes efficient use of key system resources like the CPU. Of course, one needs to measure the CPU. Fortunately, we are not talking about subtle increases in CPU usage most of the time during scanning that would require a lot of detailed data capture and analysis. To date, the usage uptick that we have seen is fairly easy to detect, as you will see shortly. So basic measurement is as easy as bringing up the Windows Resource Monitor window, starting the scan, and then observing the CPU utilization for the duration of the scan. If you require detailed statistics over time to analyze and compare across vendors and look at the detailed usage, say, by process, you can configure the Windows Performance Monitor, or PerfMon, as the program is called, to collect and store whatever detailed statistics you need. CPU, memory, basically any system of resource that is of interest to you. And of course, that's what we used for our tests. Let's take a look at some actual screenshots from tests that we ran earlier this year. It is not my purpose in this presentation to focus on one vendor over another. Thus, I won't be calling out specific vendors or products. If you are curious or want more information, you can go to our Tolly.com report website and search on endpoint security, and you will find the full report with the vendor and product information, along with the many other endpoint protection reports we've done in the past. So I can go through these next slides quickly, as the purpose is to demonstrate the CPU characteristics. Inside the circle is the running CPU graph. It's easy to spot where the scan begins as the CPU utilization goes up. PerfMon data showed 71% to 91% of the CPU was used by the endpoint process, depending on the type of scan, online or offline, and we'll be talking about that shortly as our next topic. So here's another one. Depending on scan type, online or offline, the endpoint protection program consumed somewhere between 52% and 82% of the CPU while it was running its scan. So you can see the CPU overall looks higher. That's likely driven by file management related processes. So final example here for this topic. Visually, you can tell immediately that the resource consumption here is much different, much lower. This solution deliberately throttles its use of CPU and, depending on run type, consumes between 11% and 21% of the CPU. Again, the solution names are not important, as the message here to you is awareness. Be aware that different endpoint vendors approach resource consumption differently. Depending upon your needs and your endpoint use cases, this could matter little or it could matter a lot. At a minimum, it is prudent and easy to run a quick test to make sure that your applications can still run without degradation while your endpoint security solution is running a scan. Efficacy is the core requirement of any endpoint protection solution. If your endpoint protection solution cannot detect malware accurately, well, then it really isn't a viable solution, is it? Efficacy, as we're discussing it here, is concerned only with detecting the presence of malware and not remediation, that is, removal of the malware. Neither is this particular test concerned with false positive, that is, situations where an endpoint solution classifies a benign file as harboring malware. That's important as well, but not an aspect of this particular evaluation because we have a different focus. So the benefit of high accuracy is obvious. For our test, we had a password-protected zip file containing 1,000 known malware samples that we downloaded from a community site. The test consists of decompressing the password-protected file. We unzip the compressed file full of malware, and the solution under test will trigger an on-demand scan. When that scan is done, the endpoint should have detected all 1,000 samples to get a 100% detection rate. The additional variable here is the connection state of the endpoint. Let's look at that on the next slide. We are looking at a variable that one might think shouldn't really matter. That is, the connection state of the endpoint to the internet. Backing up for a moment, in the quote-unquote old days, The endpoint solution would periodically download a static copy of its most recent threat database and reference only that when scanning for malware signatures. Today, vendors typically take a dual source approach, where they have not only a local file with threat information, but also a cloud-based threat intelligence database. The addition of the cloud-based threat intelligence database provides several benefits. First, there is no practical size limit to that database, where malware database size can certainly be an issue on an endpoint. Second, that resource is, by definition, always up to date, because it's the one that's always being updated by the threat intelligence team of the vendor. Thus, one can imagine a logic flow where the endpoint checks its local database first for a threat. If it finds a malware match there, it flags the sample and it's done. If not, it checks the cloud threat database. That way, most of the processing takes place quickly and locally without having to reach out across the internet. The endpoint only reaches out to the cloud if it doesn't find a local match and determines that more info is needed. Now, I don't know that these solutions work that way, but certainly that is how I would expect them to work. Well, why should we care? Well, we shouldn't have to, but testing that we've done has shown that the connection state variable changes the results. We'll see that data shortly. Is this relevant in an always online world? Well, again, it depends on your use case. While Wi-Fi is available on many airlines now, it's still an extra charge option on many flights. Thus, people using laptops on an airplane might often be disconnected from the cloud database while they're doing that. And for certain operations deployments, companies might deliberately turn off internet access to the endpoints to protect the device from active cyber attacks. Still, that computer might already have malware lurking on it that might get access or triggered while the computer is offline. The dwell time, how long has that malware been there before it's triggered? So this online versus offline efficacy, fortunately, is easy to test. After we download the malware corpus to our test system, but before we test, we disable any wired or wireless Ethernet connections and confirm that the internet is not accessible. Then we run the tests as described earlier and note how many files were missed. We then enable the wired or wireless Ethernet connections and run again. Let's look at some results on the next slide. Ideally, the connection state wouldn't make a difference. The results would be the same. That is, the status of the internet connection would not impact the results. However, in testing we've done now and in prior years, we have found that not to be the case. So what you see on the slide here is what we found across some 5 different well-known vendor solutions. The results at the far left, the first pair of bars, show a solution that detected all malware, 100%, both when offline and online. So no difference there. The other solutions had different results when the connection state changed. Let's move first to the 3 bars on the right, or sets of bars on the right of the graph. So they make sense, to me at least, in that the efficacy is higher when the endpoint has access to the additional cloud-based resources. When that resource is not accessible, when the solution is offline, the efficacy, the accuracy drops. In one case, it goes from 99% to 75%, and in the other cases, less dramatically, a few points lower, from 95 to 91 or 99 to 92, but still drops. And that means that the difference, the delta there, is that malware would not be detected and would get through and potentially harm your endpoint. Now, one thing we also look at here too is the set of bars second from the left has results that didn't make sense to our testers. So we reran these tests and got the same results. So we believe that they're accurate. Strangely, this solution had better results when offline than it had when online. I can't explain those results, but I can say that we ran that same test multiple times and got the same results. So ultimately, the point to note here is that in most cases, the connection status will directly impact efficacy results. So, if offline use is important to your environment, be sure to run efficacy tests both online and offline, note the differences, and understand the potential impact of those differences on your operating environment. So, last topic here. This slide is not about lab testing, but rather about awareness. For the entire history of endpoint protection, these products have been single vendor solutions. That is to say, one solution, or the one solution that would detect the malware, is the same solution that would remediate or remove the malware from the endpoint. With hybrid solutions, one vendor solution identifies the malware and partners with another vendor's solution that removes the offending malware. Well, why could this approach be important? Well, the small footprint approach used by at least one vendor, discussed below, can bring endpoint protection to an entire group of currently unprotected endpoints, that is, IoT devices. Already today, we have many IoT devices on our corporate networks. Obviously, it varies based on the type of network, but in most cases, you'll see there could be cameras, sensors, HVAC controls, industrial controls, whatever. Most of them based on a Linux operating system environment. They are fully capable of being taken over by malware and inflicting damage on corporate resources, maybe even participating in launching a ransomware attack, and are rarely covered by any endpoint protection solution today. So one example of this new approach is a company called Critica Security. We haven't done any work for them, but we have been briefed, and I found their approach certainly intriguing. Their focus is on creating small footprint solution that can run not only on traditional endpoints, but also on IoT devices. Their claims are that it reduces dwell time, that is, the time that malware sits on a device before it gets detected. In the case of IoT, as noted, this could be a game changer by finally having a solution to protect the growing number of IoT devices on our networks. So again, I don't have any personal experience with this, but here is a comment I found on their approach by a fellow named Ben Badgerin, who's a principal analyst and CEO of Creative Strategies, Inc. Quote, their approach, meaning Critica, uses an extremely small probe or agent, they'd say less than 70K bytes, very tiny, that can scale from server to IoT endpoint. It has continuous monitoring for any changes to a device's executable code, resulting in no false positives and a distributed intelligence approach that leads to the detection of never seen before malware, end quote. Downside here, of course, is that a partner vendor will be needed to take care of the remediation. Still, this could be as significant because we haven't really seen any changes to the general quote-unquote architecture of endpoint solutions in a very long time. So I wanted to make mention of it, not to promote it, as I frankly don't know much about it at this point, but rather just to make you aware of it. Let's review what we have discussed today. Efficiency always matters, and for certain environments, excess resource usage can be a showstopper. Be aware of the resource usage characteristics of any endpoint protection solution that you buy. Make sure that its usage characteristics don't translate into degradation for the types of applications that you run. Efficacy, of course, always matters as well. While we naturally assume that every device has a constant connection to the internet, that is not always the case. And in certain environments, such as operations, quote unquote, offline, disconnected from the internet is the desired state. Be aware that some systems' efficacy will change, usually for the worse, if the device is deliberately or inadvertently cut off from the internet and its company's threat database. Finally, be aware of the possibility of implementing a hybrid approach where you use one vendor's solution to detect threats and another vendor's software working in tandem to remove and remediate the threats. This approach may be something very, very new that we'll see, especially as people deal with non-traditional endpoints such as IoT devices. While we have been speaking today in generalities and deliberately not mentioning specific vendors, you certainly can find out a lot about what specific vendors do by visiting our Tolly.com report library. These are all free of charge access for detailed vendor-specific reviews on endpoint protection and many other enterprise, SMB, and service provider class information technology solutions. So be sure to check it out. Thank you for your time today. I hope that you found the session informative and enjoy the rest of the virtual summit.